Right, so now we come to the having to create the thread. Now this is also done in the wizard. This time we pick the threading wizard. This brings up the page which allows us to specify all the parameters we need for the thread. Now on the Emco lathe there is no tool changer, so we're best to leave this part as 0, leaving the tool number as 0 so that it doesn't try to initiate a tool change. The spindle RPM we can't control, but we know that in this particular example the spindle is running at 1550, so we will set that as the base speed for the spindle. The start point of the thread is at 0, but we want the thread to be 10 millimeters long. This is towards the headstock, so in this part we put -10. Now we know the pitch of the thread we want to create is 1.5 millimeters, so we can put the pitch as 1.5. We know the start diameter of the material we have now is 19.5 millimeters, so you put that as the start, and we know from the charts that the inside diameter of the thread now has to be 18.2, so we specify that as 18.2. The cutting depth of the material, we can do this very much the same, have a 0.3 cut for the main roughing, and we'll finish off with one spring pass, which means it will pass through the material one time at the final cutting depth. Now we may want to look at the other settings here. You can see we have the spindle set for clockwise, we have no coolant. We can specify the X and the Z clearance, so when it finishes the cut this is how far it retracts away from the material. The infeed angle is set to 29 degrees. This is the angle of the thread, which if you're cutting a metric thread the angle is generally 29 to 29.5. You also can specify the last and the minimum pass depths for part of the cutting. This is all okay on here, so we will go back. Now all these parameters now being in, if we post the code we can see that the thread will be cut in 20 passes with one spring, and the axis will move at this speed, it will accelerate in 2.5 units. This means that the tool will take 2.5 millimeters to accelerate up to speed, so we need to be able to start the tool at least this distance before the start of the cut. So at this point we can move the Z start to 5 millimeters. This means the tool will come up to here and start accelerating, so by the time it gets into the thread it will be running at speed. If we try posting the code now we can see it's actually drawn it longer, but we know that the material starts here, but once again still 20 passes. At this point we can post that code. If you wish we can save the settings so that next time we come back to the page these settings are still here, and exit back. Now the material we now know is at 19.5, so we should set this now as the part 0. If you want to move the tool onto the new tool onto the edge of the material, onto the corner to that point, we can now click part 0 for these 2 points, which now sets the axis position up here. Pressing the cycle will bring up the code. So see, this is the code that has been generated for the cutting of the thread. For the most part it is just a G76 CAN cycle, and in this window we can see the thread and the tool path that's created for us. At this point now all we need to do is to press the cycle start and we will have a thread.